Hi students, this is the first lesson, main lesson in integration. In the differentiation chapter, we have studied this one. So let me write here a few examples. Say for example, d by dx of say sin x, if you take, this is cos x. Let me take another. Say d by dx of say secant x, if you take, this is secant x tan x, and d by dx of, for example, you have seen this also, tan inverse x you have done, it is 1 by 1 plus x square. So this is the process of differentiation. Now what is integration? What is integration? So what you have to think is, suppose, see here, d by dx, you can imagine that it is an operator. D by dx of something you are putting here, then you are getting some other function. Say when you put sin x, you are getting cos x. Secant x, you are getting secant x tan x. Tan inverse, you are getting 1 by 1 plus x square. Now the question is, I want to find a function, operator here, which takes say cos x, this must be equal to sin x. This should be sin x. Similarly, I should be able to find secant x tan x. This should be equal to secant x. And similarly, 1 by 1 plus x square, this should be equal to tan inverse x. Meaning, I want to find another operator similar this type, so that when I operate this function, I should get sin x. When I operate this function with that operator, you should get secant x extra. That is the thing. So that is known as integration. So we have to use a symbol. So this is the symbol we are using. And then here d by dx, but here we write dx here. Similarly here, so what we do is we write this symbol. This is the symbol of integration. Then we write dx. This is symbol of integration here, then dx. This is the meaning of integration. That is, it is the reverse process of differentiation. When you differentiate a function, you get another function. Now when you integrate that function, you should get back the original function. So that's the thing. Therefore here, d by dx of something equal to x. Here, integration of something dx, that must be equal to some other function. So now, if you write here a general function f of x, if this is equal to f of x, then here if you put this function f of x, you should get f of x. So this is the meaning of integration. And we use the same symbol. Since the process is reverse, you see here, this is understanding, dx is below, d by. Here indicating that it is a reverse process, dx is multiplied with this function. So this is a symbol. Here the symbol is d by dx. So that is a symbol. Here it is integration. This is a symbol. So this is the meaning. Now we have to understand some of the parts of this one. This is of course symbol of integration. This function is called integrand. And this is called variable of integration. Or integral. And this is called antiderivative. This is one name. Or it can also be written integral. So the integrand, it is integral. So these are the things. Therefore, you can understand in a very simple way what is integration is. It is just the reverse process of differentiation. Therefore, by this definition, it is very clear. Whenever you want to get a formula for integration, first thing is you should know what is the corresponding differentiation formula. So now let me define what is integration. Then we shall work out a few more examples. So the definition is this. You consider a function f of x. and another function f of x such that it is defined in an interval, real function defined in an interval I, such that if d by dx of this f of x, capital letter f of x, if this is equal to f of x, for every x belonging to I is the domain of this function, then the definition says integration of f of x dx, this will be equal to f of x. So this is the meaning of integral. Now let me give a few examples. For example, d by dx of x cube, this is 3x square. So that means this is our, always you have to remember this way, the function which you are differentiating, that is capital F of x, and the function which you are getting, that is small f of x. So then in the integration, it is small f of x, that means I have to write this one. So 3x square, then dx, this equal to x cube. So this is the understanding. Now there is one small problem. The problem is this: we write integration of f of x dx equal to not only f of x, we add a constant c. And this constant is called constant of integration. Now you may have a doubt, why should we add c here? So this can be made clear with the help of the example. Let us take, for example, d by dx of, let me say, x square. If you take, this is 2x. So this is our capital F of x, this is our small f of x. So by definition, therefore, 2x dx will be equal to x square. Now suppose I take d by dx of x square, say plus 1, instead of x square plus 1. But this side it is 2x only, because differentiation of 1 is 0. So this becomes f of x. This becomes capital F of x. Now suppose one student takes this one as the definition. His answer will be this one. Suppose another student takes this as the example. Then what happens is, I have to accept this answer also. X square plus 1. Another student says, I will take this one. d by dx of x square plus 2. This is also 2x only. So when you integrate this one, here you are getting x square plus 2. So there is a problem. How to compensate this one? So what we do is, we write a constant c here, and this constant, therefore it is called constant of integration, and this integral is called indefinite integral, because we don't know the value of this. It can be 1, it can be 2, or it can be any other constant also, because any constant when differentiated, it becomes 0. Therefore we have to add the constant c after the integration, whatever may be the function here, f of x. Condition is only this: differentiation of f of x must be f of x. That is the first condition. Then we add a constant, because even if you add constant here, it will not change. So that is called constant of integration. Now let me first sum up what I have presented before you as a new idea. So first thing is that, number 1, integration is a reverse process of what? Differentiation. This is first thing. Then this you have to remember, symbol is this one. Then f of x dx we write, this equal to f of x, but we have to write c, and you have to remember the name. This is symbol of integration. This function is called integrand. I have already told you, integrand. And this is variable of integration. This is the integral of this function, one thing, or it is also called antiderivative. So two names are same, identical. Then c is constant of integration, and this constant is a constant, no doubt, but we don't know what is its value. So that's why it is called indefinite integral. So this is a basic idea of integration. I think I made it clear. Now The next concept is we have to derive the formula, but before that let me take a few examples to make ourselves familiar with this concept. Let us say, for example, d by dx of, suppose I take x, this is 1. So definitely integration of 1 dx will be x, but what I have to do is I have to add c. Suppose you take d by dx of, say, sine inverse x. We have studied this one. This is 1 by square root of 1 minus x square. So we know the differentiation of sine inverse x is this one. Therefore, definitely integration of dx by square root of 1 minus x square, this is sine inverse x. Of course, I have to add c. Like this, actually, taking a function, we can find what is the integration and then we can write in the reverse order. But you can't do this every time. Say, this can be done like this also. Suppose you ask me, what is the integration of cos 2x dx? I can't direct, now I have to think in the reverse order. Differentiating which function, you get cos x, cos 2x, not cos x, cos 2x. Now, if you guess that it is sine, you are wrong. Suppose you say it is sine 2x, that is wrong. Because problem is you differentiate this. Of course, you can also say, sir, this is c. If you differentiate this one, you get cos 2x into 2 you get, because differentiation using chain rule. Therefore, here, if you differentiate d by dx of sine 2x divided by 2, then you see this is our capital F of x. When you differentiate this, you get cos 2x only, because differentiation of 2x is 2, but that 2 will be cancelling with this 2, so you get this. So integration of this is sine 2x divided by 2. See, this way of doing the problem is very, very difficult. Only for a few examples we can do, in some it is not possible also. Therefore, now we should know how to find the list of integrals, the way we have done it in differentiation. Say, for example, we have a list of formula for inverse trigonometric functions, a list of formula for trigonometric functions, then exponential function, log function, algebraic function, etc. Same way, first we have to write the list of integral formula. That is what let us begin today. Of course, depending on the availability of time, I will list the formula. In the next session, we will continue. So, list of formula. List of formula. First one is algebraic. Now, first I will write the formula. See, integration of xn dx, this is x power n plus 1 by n plus 1. Let me write the formula first. Then, of course, even if I don't write, you have to write it. It is c. C is a must constant of integration. Now, you may wonder how it is xn dx equal to x power n plus 1. But there is one condition. N should not be equal to minus 1. That is one condition. Because when n is, it is obvious. When n is minus 1, it is 0. So anything by 0 is not allowed. Therefore, this is valid only when n is not equal. Any other value, it is valid. Now, you may wonder why it is this formula. See, it is very simple. You know that if you take this as small f of x, this should be our capital F of x. So, you check now. So, if you differentiate this, what will you get? d by dx of, if you differentiate x power n plus 1 by n plus 1, what do you get? N plus 1 is a constant, you get outside. Then use the differentiation formula. It is n plus 1 into x power n. So, formula is this, d by dx of x power n is n into x power n minus 1. So, instead of n, it is n plus 1. So, it is n plus 1, then n plus 1 minus 1 is n. But these two cancel. So, you get x power n. Now, look here. Therefore, integration of this must be this. So, that is the reason. So, this is the first formula, that is algebraic formula. Let us work out a few examples using this formula so that it is very clear. Say first example is, what is the integration of, say for example, x square dx? Suppose you take. So what is n? See, condition is that n should not be minus 1. That's the only condition. So this will be equal to, n is 2 here. So according to definition, so x power 2 plus 1, n plus 1 divided by 2 plus 1. This is x cube divided by 3, but I have to add c. Now every time in the beginning you can check whether it is correct or not. See, you differentiate this one, what do you get? 1 by 3 is constant. Then differentiation of x cube is 3x square. So what do you get? You get x square, because 3 cancels x square. Similarly, second one is, I can take, say for example, x, say 1 by x square I will take, because this formula says except n equal to minus 1, any other value you can take. So this we can write, of course dx I should write, even if I don't write you have to write. So this is x power minus 2 then dx. So you have to, so what is n now? N is minus 2. So formula is therefore x power minus 2 plus 1 by minus 2 plus 1. This is x power minus 1 by minus 1, but plus c I have to add invariably. So this is minus 1 by x plus c. So this, similarly, even if it is a fraction also it is correct. Say for example, I can take root x then dx. This also I can take. Say it can be written as x power half then dx. Now apply this formula. N is half here. N is not integer. It can be anything. So this is x power half plus 1 divided by half plus 1 plus c. Of course you have to simplify this one. This will be 2 by 3 x power 3 by 2 plus c. Now let me give one more specific formula. Suppose I have integration of 1 dx. How to do it? Can I apply this formula? So that is interesting. So what is 1? Actually I can write this as x power 0 dx, because whenever x is not 0, x power 0 is 1. So 1 can be written as x power 0 for any value x except 0. So this is now, what is n now according to this? It is 0. But other than n equal to minus 1, for any other you can use this formula. So what you have to do is x power 0 plus 1 by 0 plus 1, of course plus c, which is x plus c. Now you can check whether it is correct or not. See, when you differentiate this one, what do you get? Differentiation of x is 1, you get this. Differentiation c is 0, so you get. So this is the first formula, that is algebraic formula for integration. So we have to remember this one, it should not be minus 1. So this is first integral formula which we have derived. In the next session, let us take the next set, that is trigonometric formula you have to take, then we have to derive the formula, then the inverse trigonometric function also have to take, then exponential, then log. So please subscribe if you have not subscribed yet, and share with your friends. If you have subscribed, please watch all the lessons in the sequential order, because I am putting all these lessons in a playlist. So you can go to the playlist and watch all the lessons. If you just watch one lesson in the middle, you will not follow. Right from the beginning, you have to follow all the lessons. Hope you will find this useful and you enjoy. Let us meet in the next class. Till then, bye. Take care.